So today I will spend this hour for internals preparation. Okay, so probably you have received the information regarding the internal test, correct? So the first week of May, first internals will be held. I don't know to what extent these score will be considered for your final IA. Okay, nevertheless, an online MCQ based assessment will be carried in the first week of May. Okay, and from the Department of Electrical Engineering, we have decided to keep the portion for first internals is module 1. Okay, that is about DC circuits. Okay, and in module 2, okay, we will have only part A, that is single phase AC circuits. All right, single phase AC circuits. So in module 1, first part is DC circuits, and second part is fundamentals of AC. Okay, so this is the portion for first MCQ based test. Okay, the same syllabus holds good for other branches as well. So if at all your friends are studying in physics cycle in other branches, you can pass on this information. So complete module 1, that is DC circuits as well as fundamentals of AC, along with a part of module 2, that is till single phase AC circuits. Now, considering keeping this in mind, the other day I had conducted the quiz, and few of you have done well, and few of you couldn't. I won't say bad performance. You couldn't get the answers right. Now, there's a motivation behind keeping the time-based quiz. Normally, what happens in Google Forms, I just set the timer as, say, 1 hour, correct? And what you will do, whatever you know, you start ticking the answers, and whatever you don't know, you will start asking the answers in your WhatsApp group. So what will happen with a you can say illegitimate way of helping each other, correct? So you will help each other in securing the right answers. Fine, you will get some marks, which is good. But where is the learning? The learning will not take place, right? Now, the people who have honestly solved the numericals or honestly found the answers, they will be like benefited, because they know how to solve those problems and they know how to answer to that particular theory question. They will not have any problem. Now, people you have on the other side, right? There are people who they normally depend on their friends' answers. So what they will do, they'll ping their friends and they'll say, "Hey, Macha, send me the answers." Okay, fine, you will get the marks. But in externals, what you will do? How you will save yourself? Your friends cannot help you, correct, in externals. So keeping that in mind, I had used a different approach while setting up that quiz, correct. Now, other day what happened was I had set a timer for each question, as well as I had shuffled the order also. Yeah, I know, nevertheless, whatever I do, still you will be able to help each other in getting the answers. That is fine. I mean, it is not fine, but I cannot avoid, correct. I have my own limitation. Okay, but still from my side I made an effort to make an individual student to understand his or her capacity when it comes to understanding the fundamentals. So yesterday I had set 30 questions, and all were fundamental questions. And even in your MCQ based assessment test, you can find similar problems or similar questions. Okay. So I would request everyone to go through with those questions, the yesterday's quiz, as well as the quiz which I had given, say about a week back, right? I had given one more quiz on single phase AC circuits, as well as DC circuits. So please go through with those quiz questions. It will greatly help you in attempting the MCQ assessment that will be taking place in the first week of May. All right, fine. Now, one by one, I mean, if at all you have any doubts, you can ask me. This is going to be a kind of feel-free session. So, if you want me to, clarify some of the things, you can just let me know. Okay, I'll try to help you out. Okay. And attendance, as usual, seems to be very poor. It is, I can see on the screen, only 18 people are absent. So we are left with only one way, that is hook or crook method. So what we have decided is we will start calling your parents individually, and we want to know what exactly the problem is. Okay. It's too much. 18 out of 63 is too much. The moment I pose a test, I see that around 58 students are taking up the test. I do not know whether they are giving proxy to you, or you can do that, right? You can give your credentials to your friend, and you can ask him or her to log in on your behalf, and you can make that test happen. That's not the right way, actually. Right way. Okay. Because along with the system, even I mean, teaching fraternity as well as students are evolving. So in order to curb or curtail those, you can say that unethical ways of learning, we may come up with a different learning platform. Okay, so BMSIT is on the verge of signing a deal with TCS people. So TCS people will be providing us uh, teaching learning platform. Okay, just like your Google Meet and what do you say, Zoom. Okay, so we'll be using that in the future. Okay, hopefully we will have better access and uh, a simple approach in TL. Okay, you can ask me any doubts, okay, related to the portions. Okay, if you don't have any doubts, probably I can proceed with module 1, and I can talk about what are the important topics that you need to study. All right, you can just type proceed in the chat section. So I will be able to continue with the syllabus description. Okay, as in we'll write down the frequently asked question in the examination. Okay. All right, I assume that I'm free to go ahead. All right, so in module 1, I'll just write N1A. In module 1A, the theory questions, okay, that is DC circuits, DC circuits. Theory questions could be something like, okay, I'll not write, it's a waste of time. State and explain Ohm's law, and state and explain Kirchhoff laws. All right. So such questions you can normally expect in case of module 1. Okay, state and explain Ohm's law and state and explain the Kirchhoff laws. Now, you may ask in MCQ what kind of question we can frame. Okay, for example, if I were to consider an example of Ohm's law, so we say that Ohm's law is applicable for linear devices. So I can set a question something like in the following devices, which device doesn't obey Ohm's law? Okay, say Zener diode, resistor, let's say copper transmission line, transistor. Okay, some of this kind I can ask. Now, what will be the answer? Resistor and copper transmission lines. I can say that that's the right answer. Now, there is a catch here. Now, whenever we conduct a MCQ test, we may give you 4 options. Let's say A, B, C. Okay, I'm just considering a case. Now, in these 4 options, you may have 3 right options and 1, let's say, invalid option. Now, if you select the correct options, that is option A, option B, and option C, then only you will be rewarded with full marks. Let's say 1 mark you will receive. On the other hand, let's say you just looked at the option and you just found that, okay, option A is correct. Okay, let's say you have just marked that option A is correct, which is actually correct. But along with option A, in our scheme, option B and option C would have been the correct answers as well. So if you do the selection of this kind, then you will not be getting any marks. You will be just given with 0, because in the answer scheme, in the software, we will be enabling A, B, C options. Okay, so don't abruptly come to the conclusion. Please look into all the options. Few questions may have all 4 options as the right option. So you have to tick all the 4 options. You cannot say that, or you cannot argue that, sir, option A is correct. Then why I'm not allotted with the marks? No, that's not the case, because option B is also correct, option C is also correct. So you have to read all the options. All right. So that is one thing. Okay. Now, all theory questions can also be asked in MCQ based test. I have given an example for Ohm's law. Okay. Now, another example for theory question in module 1 could be something like this. Validity of KVL and KCL is applicable to dash circuits. Validity of KVL and KCL is applicable to dash circuits. Let's say 4 options I'll give. And in option A, I will write both AC and DC. Say in option B, only AC, only DC. None of the above. Okay. So you can expect such questions. Okay, this is A, option B, option C, and option D. Okay, don't worry about the answer. Okay, what is the right answer? A. You can apply for AC circuits as well as you can apply for DC circuits. So don't be in the impression that, under the impression that theory questions will not be asked in MCQ based assessment. Okay, you will be asked with theory questions. You can say of this kind. All right. Fine. So that's about the theory questions related to module 1. Okay. You may also get questions something like this. Okay. Let's say the problem statement is something like this. 2 resistors R1 and R2 are connected in parallel, and the combination is connected across a DC voltage having V volts. Identify the correct current relation. Okay, so two resistors connected in parallel, and the combination is connected across a DC voltage source having a voltage of V volts. Identify the correct current relation. Okay, so let's say this is also a kind of theory question, right? Because in your conventional exam, we would have asked something like for a voltage, for a current division, for a current divider circuit, derive an expression for branch current formula. So that is the question basically. Now in MCQ, that question can be asked in this manner. Identify the right current equation for the given circuit description. Okay. So what do we have here? We have 4 options. Okay. So you have to identify the right option. Now, how do you identify the right option? You should derive, right? But nobody will ask you how did you get the answer, whether you derived and obtained the answer or whether you memorized the option. Nobody will ask. Okay, we will be bothered only about the right answer. All right. So your current division rule can also be asked in this type whenever it comes to MCQ based assessment. Okay. So can anyone tell me what will be the right option for current division rule?
Option A and B.
Right. Option A as well as option B. Because this is for one branch and this is for another branch. So such questions you can expect in this particular exam. All right, and it is compulsory for all. Now, what made me to spend this hour for this particular explanation is due to, see, we around 6 faculty members are handling basic electrical engineering. So I do not know which faculty is going to set the question paper. Okay, so that's the reason I am trying to, touch upon the important aspects of module 1 and part of module 2. Okay, so please concentrate. And you can also expect some questions on voltage division. Let's say, for example, the question may be of this kind. 2 resistors R1 and R2 are connected in series. Identify the correct voltage division expression. If that is the question, how are you going to select the right options? To select the right options, please go through with the individual options. Say, for example, let's say option A is V1 is equal to V R2, R1 plus R2. V2 is equal to V R1, R1 plus R2. And say option C is V1 is equal to V into R1 divided by R1 plus R2. And D is, say, V2 is equal to V into R2 divided by R1 plus R2. Okay. So R1, R2 are connected in series, and the combination is connected in series with DC supply having a potential of V volts. Identify the correct voltage division relation. Okay. Can anyone tell me what could be the answer?
C and D.
Right, C and D. Okay. So hope I'm able to convey the message. So you can expect questions of this kind, all right, under theory section. Okay. Numericals, you don't have any problem because you will be given with the quantity, right? You will be given with quantitative data. So you will have to just substitute that data into the equation and get the value of the required variables, current variable or voltage variable. Okay. So that's about the theory questions in module 1. Okay. Let's say, do I have any other questions in module 1? Yeah, single phase AC. Single phase AC. Single phase AC. So I will not bifurcate this single phase AC something like part of module 1 and part of module 2. Okay. For me, single phase AC is a whole concept. Okay. Based on the syllabus distribution, you can take up module 1B part and module 2A part. Okay. So in module 1, we will be talking about the fundamentals of AC, as in the definition of AC, frequency, amplitude, peak-to-peak voltage, RMS value, average value, RMS value of sine wave, RMS value of the DC value of sine wave. Such questions you can expect in case of module 1. That is under fundamentals of AC circuits. Okay. Other day I had asked one question, right, about frequency. Okay. So a wave is represented by something like, say, frequency of this value. Okay, and I had given some options. Okay, in that 3 options were correct, but most of you have had ticked only one particular option, which is incorrect. I have multiple correct answers, so you're supposed to select those correct answers. That's how this MCQ test works. All right, so you have to be very careful from here onwards. All right, now what I will do, since I need to discuss about single phase AC, you have to concentrate the following theory topics. Okay. Ideal capacitor behavior. Okay, you can say ideal element behavior. I will say behavior. Behavior of ideal elements practical elements. Now, when I say behavior of ideal elements, what are the ideal elements? Pure R, pure N, pure C. So pure R, pure N, pure C can be considered as the ideal elements. Okay. And what are the practical elements? When you say practical elements, it could be something like RL circuit, RC circuits, and let's say RLC circuits. Okay. So you may be asked several questions based on the circuit behavior. Right? For example, other day I had asked which of the following is a right statement. In case of a pure capacitor, current leads voltage by 90 degrees. Okay, one option. For example, let me rewrite. In case of pure capacitor, identify the correct statement. In option A, V lags I by 90. Say option B, V leads I by 90. And in option C, I lags V by 90. And in option D, I leads V by 90, which is the right answer. When we draw the vector diagram, you had drawn something like this. This is I, and say this is V, right? And this is the phase separation, which is pi by 2 radians or 90 degrees. So this is our vector diagram for pure capacitive circuit. And this is the angle of rotation, omega. Omega. Now, what is the right statement for a pure capacitive circuit? Voltage lags current by an angle of 90 degrees. Is it correct? Yes, it is correct, right? This is your current and this is your voltage. You can clearly observe that voltage is falling behind current by an angle of 90 degrees. So this option is correct. V lags I by 90 degrees. This is not possible, right, as per the vector diagram. And you can also say that current is leading the voltage by an angle of 90 degrees. D. So you have two options here, two correct options. So you are supposed to tick both these two options. Okay, so in competitive exams and all, you will be given with such options. It's not like only one options you will have. You may have multiple correct options. All right. So this is the answer. So similarly, this question may be rephrased for a pure resistive circuit, for pure inductive circuit. Okay. And a question may also be asked in terms of power. For an ideal inductor, the supplied energy is stored in its dash: magnetic field, electrostatic field, electromagnetic field, etc., etc. Okay, so such theory questions may be asked in MCQ based test. All right. Okay, let's say just to test your practical circuit knowledge. Say, for example, let me ask the question of practical circuit. Let's say in a series RL circuit, in a series RLC circuit, identify the correct current relation. In a series RL circuit, identify the correct current relation. So I have taken an example of RL circuit and I am asking you to identify the correct current relation. Let's say these are the 4 options I have given. Okay. Can anyone point out the right option?
So B.
Which one?
B, sir.
Option B, right?
Yes, sir.
Yeah, option correct. So that's how the theory questions may be asked. If at all, if it was asked for a descriptive question, you would have drawn the vector diagram, and from the vector diagram you would have written V is equal to Vm sin omega t, and you could have mentioned something like, as seen from the vector diagram, the current is lagging behind the applied voltage by an angle phi. So we can write I is equal to Im sin of omega t minus phi. Right. That's how we handle the theory questions in a descriptive type of examination. So in MCQ type, such questions you can expect. All right. Fine. So such questions you can expect, theory questions you can expect from practical RL circuits. Okay. And you can also expect questions. Okay, you can just make a point. Okay, note down based on impedance triangle, and power triangle. Okay, so based on power triangle, very, very important. Very, very important. You can expect one or two questions from, only from impedance triangle and power triangle. So, what is that you should know? You should know the power, say, impedance triangle, for, say, RC circuit. This is R, this is XC, and this is phi. And similarly, you should also know the impedance triangle for RL circuit. So for RL circuit, you will get the impedance triangle of this kind. This is phi, this is XL, and this is resistance R, and this is Z. Okay. So probably you will be given with power factor value along with, say, resistance value, and you will be asked to find the reactance and impedance of the circuit. Okay. So such questions you can expect from impedance triangle section. And from power triangle, okay, other day you have solved, right? From power triangle, you can expect questions related to finding out the real power and the apparent power and the volt-ampere volt-ampere reactive power, which is nothing but quadrature power. Okay. So power triangle. This is S, this is Q, and this is P, and this is your power factor angle phi. Okay, so important formula will be S is equal to P square plus Q square, and P is equal to S cos phi, and Q is equal to S sin phi. Okay, so this is the important result you would be needing to handle power triangle based problems. So such problems you can expect from RL, RC, and RLC circuits. If I were to recall the test performance of single phase AC circuits, not the, I'm not talking about yesterday's test, probably a week back, right? Last Monday, I had given a test on single phase AC circuit. I was not happy with the results. Okay, most of you haven't done well. I could say most of you in the sense more than 90% did not do well in that particular test. So please look into those questions, because in MCQ test, steps will not carry any marks. You will have only the digital logic, either 1 or 0. All right. So you have to be very careful while handling problems of this kind. Okay. Let's say you have some impedance Z1. Okay. Connected in series with a parallel combination of, say, Z2 and, say, Z3. Okay. Question could be something like, what is VAB? Okay, what is VAB? You may be having the impedance values and the current values. Okay, and the question could be, what is voltage across the terminals A and B? So you will be given with 4 options. How will you solve? You have to solve this particular question, side by side, right? So apply the current division rule or any method which you find it apt can be used to solve this problem. Okay, so please concentrate on this problem, this type of problems. Okay, this type, and as well as you have something like simple two impedances connected in parallel, and you will be asked to find what is the branch currents. Okay, and you can also ask something like what is the circuit power factor. So such questions can also be asked. So enormous effort is needed to solve these problems. So you have to make your hand dirty in order to get the right answer. So please don't rely on your friend's answers. Start solving, because remember always one thing, during externals, you have to attempt these questions. Okay, so please take it as a advice from my side. All right, so please try to solve on your own. Okay, so any doubts you have, you can please ask. Any doubts about the question paper pattern or something? I have told you get theory questions as well as you can get problematic questions. Okay. Now, any doubts in the previous quiz?
So the quiz will be like yesterday's or in the Google document.
Could you please come again? I couldn't get it.
Yesterday's test, like a quiz you gave, no, that with the timing for the questions for each questions, like that it will be there.
I don't know, man. That's what I was mentioning in the beginning. I do not know what kind of test, because see, from teaching fraternity, like we will just set the questions. That's all. So far, we did not get the information, but I am suspecting such type of assessment will be carried. That's the reason I prepared you guys for the worst case. So I had set the timing. If it's not given, well and good, right?
Yes, sir.
Yeah, that's the reason. All right. So I do not know. I will let you know the moment I hear about it. All right. In the group, I will let you know.
Sir, will there be 50 questions or 30 questions, sir?
As per our HOD's just a minute, HOD's information, I guess it is 30 as of now. All right.
Yes, sir.
Okay. Just let me know. Are you able to see this quiz screen?
Yes, sir. Yes, sir.
Yeah, you're able to see, right? Yeah. Let us just go through with the questions. Okay. Don't worry about the marks. I'll say this, and in the end, I may consider these marks also. I have that bad habit of saying, don't worry about marks. Okay. All right. So the first question was like, what is a passive component? Correct. So resistor, inductor, capacitor, transistor. All three are passive because they do not possess energy on their own. Okay. And transistor is not a right option because it doesn't fall under conductor category. It falls under semiconductor category. So that's the reason you can keep it out, transistor. So first three are the right options, right? Yeah. Second options. Second question is something like, the use of inductor. Yeah, the use of inductor, it was asked, like passive component that store food or store energy. Yeah, the second option, right? Okay, what is period? Yeah, let me talk about only few questions. What is period? Time required for a sine wave to complete one cycle. That is correct. Unit is equal to second. That is also correct. It is equal to frequency. No, frequency is cycles per second. On the other hand, the last option, time period, t is equal to 1 by f. That is also correct. So this question number 3 actually had multiple options. So you were supposed to select option A, option B, and option D. Okay, so that's how such questions you may get in your internals. Okay, amplitude here also. Many of you have made an error while identifying the amplitude. VPP and IPP, they are different, right? Your peak-to-peak voltage is 2 times the amplitude. Similarly, peak-to-peak current is also 2 times the current amplitude. So option A is not the right answer. So VP or IP is one of the answer. And positive and negative maximum value of the sine wave, that also can be considered as the answer for question number 5. Okay. Yeah, then RMS value, correct, RMS value. Most of you have selected VRMS is equal to 0.707 into VP, which is correct. And it is also called as effective voltage. That is also correct. And can be read using multimeters. Yes, whatever multimeters you use in your lab, they register basically the RMS value. And option number 2 says the main supply in our home is 240 volts. So that is the RMS value. That is also correct. So basically in question number 5, all 4 are the right answers. Okay. So what I'm trying to tell you is that, whenever you have been given with the options, you have to read the options carefully. Okay. Yeah. This is pretty straightforward. Question number 6. Yeah, this is also pretty straightforward. I think produce the same amount of heat as produced by AC when flowing through the same circuit. Okay, it's given as same circuit. That's fine. Same circuit. Question number 8. Sinusoidal wave has a frequency of 50 hertz with 30 amperes RMS current. Which of the following equation represents the wave? Right. So which one? Question number 8. So it's given as frequency 50 hertz and 30 amperes RMS current. RMS current, right? Yeah. So you were supposed to find the expression for sine wave. So the general expression for sine wave is I is equal to Im sine omega. Okay. So this is the general expression for sine wave. Plus or minus phi also you can include. So this is the standard expression for sine function. It could be an alternating voltage function or current function. So Im, we don't have Im, instead we have RMS value. So maximum value is √2 times RMS value. So √2 times RMS value, that is 30. So 30 into √2 you have to find out. So you will get 42.4 amperes. Okay. And there is no information about phi. So about phi, no data. So phi is 0 degree then. Okay, and then you have omega. What is omega? Angular frequency, which is 2 pi f. So 2 into pi into the forcing function has a frequency of 50 hertz. So I think it is 314 radian per second. So that being omega, you can write the expression for sinusoidal current as I is equal to 42.42 sine of omega t. That is 314 into t. So this is your option. Okay. So such questions can be asked in your MCQ assessment. Yeah, so option A fits here. Yeah, purely capacitive circuit I have discussed. Any question which you did not get convinced with the options? Any question you can point out actually? Okay, see, average power in a single phase circuit is 0. This means the circuit is, it should be a pure circuit, right? Because only pure circuits do not consume power, and that too your pure inductive circuit and pure capacitive circuit. So here the option would be pure inductive circuit, because RLC circuit resistance R is present. So resistor will consume power, okay, and dissipates in the form of heat. So parallel RLC also, the moment you have a resistive element, you will have the power consumption. Similarly, pure resistance, I square R loss, right? So option would be pure inductive circuit. Yeah, so this is about question number 11, polar form. So polar form is nothing but R at an angle theta form. The question is something like V is equal to V naught sine of 314t plus 13 degree. The polar form will be magnitude and angular form, right? So magnitude, we normally consider the RMS value. So maximum value is V naught. So the corresponding RMS value is maximum value divided by root 2. All right. And so V naught by root 2 is your magnitude. And what is the angle? Pretty straightforward, right? 13 degree they have given. So directly you can write 13 degree there. So that will be the answer. Okay, so 12th question. They have given supply voltage is 100 at an angle 25 degrees. So what is this 100? You have to identify this 100 volts, right? Whether this 100 volt is RMS value or maximum value. Can anyone tell me? What is this 100 volts? This 100 volt is RMS value. Yes, RMS value. So you have to multiply with the root 2. So you will get 114. Sorry, 141.4 volts you will get. And then you think of converting this linear frequency into angular frequency. Okay, so which you will get it as omega as 157. Okay, plus or minus 5. So as you can clearly observe, it is given as plus 25 degree. So option C will be the answer. Okay, so that's how you solve this question. Yeah. So in question number 15, if you see, what are they given? RL circuit having reactance 3 ohm and resistance. Reactance 3 ohm and resistance under root 3. Power factor will be what? Right? So I don't know. Most of you haven't solved this. So it's given that reactance, that is XL, is 3 ohms, and resistance R is equal to under root 3 ohms. Okay, let me just confirm first. Yeah. Reactance 3 and resistance under root 3. Correct. And you have been asked to find out the power factor here. So you write it in complex notation or complex form. So complex form going to be Z is equal to R plus JXL. Okay. So R is under root 3 plus J into XL. XL is 3. Okay. So you can find out phi as tan inverse of XL by R. Okay, and power factor is nothing but cos of phi. So XL is 3 divided by root 3. And that's 3 basically. So 60 degree. And cos 60 is 0.5. So power factor for this circuit is 0.5. Okay, this is how you solve. Okay. Okay. Yeah, this is question number 16 is straightforward. You have to convert it to rectangular form. So what you can do is 230 volt. So 230 volt, you need to convert it to RMS value. That is 230 divided by root 2. Okay. And you also mentioned, let me solve this. So V is equal to 230 sine of 314t plus 46 degree. Okay, and you need to find the rectangular form, right? So first you find out the polar form. Okay. So first you find out the polar form. So polar form means R at an angle divided by root 2. So 230 by this is V is equal to Vm sine blah blah blah. Correct. So RMS value so 230 by root 2. 162 60 and theta is 4060 4060. Okay, and then you can directly convert it to complex the complex form, right? So 162.63 at an angle 46. So you will get R value as 112.97 plus 116.98 I. I or J, doesn't matter. So that's the answer. So you can just search the answer. 112.97. Okay, I have here plus 116. Yeah, so this will be the answer. Yeah, the option B is the answer. Okay. Okay. Yeah, and this equation was given, right? You can clearly observe that. Yeah, you can clearly observe that the wave is not starting from origin. Hence, it cannot be a sinusoidal function. The wave is starting with a negative maximum value. Hence, it has to be a cosine function. Basically, it's a negative cosine function. So that's how you can start selecting the choices. Okay. And the period is, you can say, time completed. I mean, time taken by the wave to complete one full cycle. So based on that, you can select the period. So basically, it's a negative cosine function. So it has to be minus cos 2t, right? Yeah, the first option, minus, because the wave is starting from negative, minus 1. So minus 1 into cos of 2t. Okay, where 2 is nothing but omega. Omega is 2 pi. So basically, you have to identify the full cycle. Okay, so let's say if you start from here, okay, this is your negative half cycle, and the next negative half cycle you have to track. All right, so that's how you find out the time period. Okay. So all right, so you go through with the questions. Okay, if you have any doubts, please revert. Okay, you can ask me if at all you haven't understood the concepts. All right then. So I will conclude this session for today, and tomorrow let me start with module 4. Okay, so I'll start with a fresh module 4. Okay, thank you very much.